Welcome to the cbse chemistry lecture series. In the last video we discussed about the estimation of nitrogen by Dumas method. Now in this particular class we are going to discuss about estimation of nitrogen. That's another method. Name is Kjeldahl method. In this Kjeldahl method we can also estimate the amount of how much amount of nitrogen is present in the organic compound. So this is normally the nitrogen which is present in the fertilizers, foodstuffs, drugs, etc. So however this compound is not applicable to the ring containing compounds like pyridine and quinoline. Okay, so now we will see the principle of this method. That's a Kjeldahl method. In this principle, first you can take an organic compound. In that organic compound we are suspecting nitrogen is present in the organic compound. When it is treated with a concentrated sulfuric acid, so what will happen? This will be converted to ammonium sulfate, NH4 twice SO4. So the nitrogen present in the organic compound will reacts with what? Concentrated sulfuric acid and to form a salt ammonium sulfate. That ammonium sulfate is further treated with sodium hydroxide. Okay, so what will happen means this will produce ammonia gas along with sodium sulfate Na2SO4 and H2O. So this is not a balanced equation, just we are briefing the principle what is happening there. So we are converting the nitrogen element in the form of ammonia gas. Okay, now we can see the apparatus for estimation of nitrogen by Kjeldahl method as shown in the figure. In the left hand side we have Kjeldahl flask. In that Kjeldahl flask we are taking the organic compound of known mass W gram. To that we are adding a concentrated sulfuric acid. To catalyze the reaction we are adding a copper sulfate. What will happen? This will be converted to ammonium sulfate. Then this ammonium sulfate is carefully transferred to another round bottom flask as shown in the figure. In the round bottom flask we are having the ammonium sulfate transferred from the Kjeldahl flask, and to that we are adding a sodium hydroxide base. When these two reacts together to produce a ammonia gas, that ammonia gas is what? Passed through the Kjeldahl flask, Kjeldahl distillation apparatus. So there is a Kjeldahl trap is there. To that one the ammonia gas is evolved along with steam passing through the condenser, which is collected in the conical flask. So in the conical flask we are having a known amount of, again you can take a sulfuric acid or you can take a hydrochloric acids. Say for example 100 ml. When the ammonia gas is neutralized with 20 ml, that means the remaining unused acids approximately 80 ml will be there. So that we have to find out by back titration. We can find out how much amount of acid is left unused. Once we know that one, automatically we can find out how much amount of ammonia is neutralized with the acid. And now we can see the calculations. First we have to say mass of an organic compound. Mass of an organic compound we can say W gram. And volume of sulfuric acid taken, volume of H2SO4 that is taken, say V centimeter cube of M1 molarity, and volume of NaOH, used for the titration of sulfuric acid, that you can say V centimeter cube, small v. This is capital V, this one is a small v. Applying the molarity equation, so what is the equations? NB MB VB is equal to NA MA VA. What is that one? We have to define all these things. Say for example Na is nothing but it is a basicity. What is basicity? It is a number of replaceable hydrogen atoms in acids. that is Na. What is Ma stands for? It's a molarity of the acid. Molarity of the acid. And Va is the volume of acid taken. Similarly, for Nb, Mb and Bb, you can take like this. So if you use a, based on all these things, if it is a 1 into small v into molarity of the acid, that is what we can say base you can take, so NaOH, which is nothing but 2 times of what? Molarity of the acid into Va, that is a sulfuric acid volume, or you can say volume of the acid is nothing but small v by 2. The here basicity of sulfur, say for example, basicity of sulfuric acid is what? It containing 2 replaceable hydrogen atoms. That is why we are putting a V by 2. Okay. Similarly, volume of sulfuric acid left unused. Volume of sulfuric acid H2SO4 left unused. So how much it will be unused? That is V by 2 centimeter cube of M1. That is the molarity of the things. Now we can say volume of sulfuric acid used. Volume of sulfuric acid used, or you can say neutralized by ammonia gas. That is capital V minus small v by 2 centimeter cube of M1 sulfuric acid. But at the same time, what will happen? So capital V minus V by 2 centimeter cube of M1 sulfuric acid is similar to 2 into V minus V by 2. We are putting this 2 is nothing but number of replaceable hydrogen atoms in sulfuric acid of M1. Suppose if it is a 1 mole of sulfuric acid neutralize 2 moles of ammonia, 1 mole of H2SO4 neutralizes 2 moles of ammonia gas. Say for example, in ammonia, if you see the molecular mass is 17 grams. Out of 17 grams of nitrogen containing only 14 grams. That is what nitrogen. If you want to find out the nitrogen is equal to 14 divided by 1 liter means 1000 centimeter cube, or you can say ml, into 2 into capital V minus small v by 2 into M1. If you want to find out the percentage of nitrogen is nothing but 14 into molarity of the acid into 2 into V minus small v by 2 by 1000 into the 100. So if you want to find out the percentage means it's 100 divided by the mass of an organic compound W. Still you can simplify it. It is nothing but what? 1.4 into M1 into 2 into capital V minus small v by 2 by W. That's all. This is the formula for percentage of nitrogen. So based on this we can find out how much amount of nitrogen is present in the organic compound. This is by the Kjeldahl methods. Thank you students. If you have any doubt, please mention in the comment box. Thank you.